Let me start this off by saying my picture of my graph is not the best, but hopefully your graph looks something like a W. One of the differences of this example is that instead of looking at a function on a closed interval, we're looking at it on an open interval from negative infinity to infinity. This means all the things that the extreme value theorem tells us about there definitely being a highest value and there definitely being a lowest value do not apply at all. There might be, there might not be. We have to look at it and see. But if you graph the function on the window defined here, it should look maybe something kind of like this. And if you use the calc_min and calc_max features, if you use it once to find the green point, you should have found this point. If you use it again, the calc_min feature to find this orange point, it should be something like this. And if you use the calc_max feature, you should find the red point is somewhere around here. So the first two questions now, where is it increasing and decreasing? Not a trick question. We do want to though mention when we talk about the interval of increase, we want to talk about the x values for which the y values are increasing. So the function increases from the green point to the red point. So that would be when x is negative 1.434, this guy's x value, up to this guy's x value, which is 0.101. The function increases again in this interval. So from this orange guy's x value, which is 1.333, up to forever, so to infinity. The decreasing intervals, there's two of them. The function decreases from here to here, and the function decreases from here to here. So to describe this region, that's happening from x being negative infinity to the x value of this green point, negative 1.434. The function decreases again from this red point down to this orange point. So the red point's x value is 0.101 to 1.333. Moving along, the local maxes and mins, we've got that pretty well covered. So the local maximums are going to be, well, there's only one, and it's going to be this point right here. So the local max is 0.101 comma 1.050. It's the top of the hill. And then there's two local minimums, and they're going to be the points here and here. So here we're giving actual x and y coordinates for both. So there's a local minimum at negative 1.434 and negative 5.219, and another one at 1.333, comma 2.447. Hopefully that's making sense. I do want to point out when we're talking about local maxes or local mins, of course, you can have multiple ones, as we see here. Any top of any hill is a local max, any bottom of any valley is a local minimum. How about the absolute max or the absolute min? Well, the absolute max, we're kind of out of luck. On both sides of this function, it goes off to infinity forever, so it's not going to have any, because we have an open interval. Now, if this interval were closed, it would be a different story, but it's not, so this is the story. And the absolute minimum is the absolute lowest y value we ever get. So we can look and see which of these y values is the lowest. This should be a negative 2.4. It should be negative, shouldn't it? That should be negative. Any hoozles. My mistake. Anyway, the absolute minimum, though, would be this y value right here of negative 5.219. So, do that worksheet. Good luck. It's going to be awesome.